Hey everybody, this is Russ Altman from The Future of Everything. It's fall quarter at Stanford and classes are starting. As we enter a new academic year, it's a great time to think about how we're educating the next generation of engineers. Back in 2020, I spoke with Emeritus Professor of Mechanical Engineering, Sheri Sheppard. She's also the founder of the Designing Education Lab at Stanford, and she talked about the importance of educating engineers not only technically, but also how to bring empathy into their work. I hope you'll take time to listen. If you enjoy The Future of Everything, please subscribe or follow it wherever you listen to podcasts. It'll help our audience grow, and it'll make sure that you never miss an episode. Today on The Future of Everything, the future of engineering education. So engineers play a critical role in society, needless to say. They take basic knowledge of the sciences and of other things, and they turn it into useful solutions to problems. The first mission of an engineer really is to know how to solve problems and to do it as a professional. Now, most engineering education focuses on a few key themes. These are generalizations, but there's usually a focus on problem solving as the overarching theme, identifying problems, understanding the constraints on the solution, and then creating robust solutions. Often it's grounded in science, math, physics, increasingly chemistry, biology, and this is based on the sciences, but then bringing it to application. It's also based on other things like an understanding of the social context and the social milieu of the problem solving. And finally, there's a focus on design. This is a creative activity where you're not just learning about new knowledge, you're actually saying, I'm going to create a solution that is maximally responsive to the problem at hand. So engineers then use these skills to advance the capabilities that we have in many areas. We see the fruits of their labor in buildings and bridges, in cars and boats and planes, in the internet and communications media, and many other areas. Professor Sheri Sheppard is a professor of mechanical engineering at Stanford with accomplishments in both research and teaching. She is a mechanical engineer by training who has worked in the car industry, including Ford, GM, Chrysler, the big three, and of course at Stanford, where she is a professor dedicated to training the next generation of engineers. But she has taken that education mission further than many professors. She actually runs a designing education lab at Stanford, where she thinks deeply about the challenges of defining the profession of engineers and then making sure we prepare the next generation appropriately. She sponsors the Stanford Mechanical Engineering Women's Group, which is devoted to empowering women in engineering as one small effort among many to make sure that the discipline represents society. Now, Sheri, you teach a course in expanding engineering, culture, diversity, and equity. These issues are on a lot of people's minds these days. How is engineering profession doing in terms of preparing a diverse, inclusive, and equitable workforce?
Okay. I would say we're doing okay. I wouldn't say we're doing terribly, but when we look at who the faces are of our engineering students and of engineers, it's pretty white and it's pretty male in the United States. And those numbers, with regard to, let's say, representation of women in engineering, have gotten to be about 25% in terms of bachelor's degrees, and the numbers have leveled off. In computer science, which is sometimes characterized as being part of engineering, the numbers rose, with the growth of computer science, but those numbers have started decreasing. There's other dimensions to diversity besides gender. There's race, there's ethnicity, there's religion. And one can make the arguments this diversity matters from a social justice perspective. Engineering is the highest paying job that you can get after a bachelor's degree. And sometimes it's even referred to as the blue collar profession, because you don't need graduate education to go out and be a professional engineer. But, so it does pay well, but also it has, as you were saying in your opening remarks, incredible influence on our everyday life. I mean, if you think about from the time you wake up, you were probably waking up to an engineered product called an alarm clock. You brush your teeth, you make coffee, you get in a car or a bicycle, all of those things had engineers behind their design plus their manufacturing. And if all the same types of engineers are thinking about those products, then we're not going to really more fully get to the needs of people,
So I did want to ask you about that, because you led off, and I totally accept that there's a social justice issue in terms of access to this very kind of great, productive, satisfying profession. And really, from first principles, people should have access to it. But I wanted to ask, is there a cost to society, and what is it for not having a workforce of engineers that reflects society in a more balanced way?
I would absolutely say there's a cost. There's opportunities that aren't recognized, products that are made too narrowly because you think that the users are going to look just like you. And I was also glad that in your opening remarks, you also said engineers identify problems. I think sometimes we look at ourselves as, okay, somebody gives us a problem and we solve it. But we also need to be part of figuring out what are the problems or the domains that are worth working in because of added value to society as a whole. And so being at that table too, and if you've got people with a wider range of life experiences at that table to say, what's important for us to solve and what's maybe we don't solve with technology, we solve with some other policy approaches, you're going to get to better problems.
So when I was writing that introduction, as you heard, I said that in many ways the core of engineering is math, physics, and then the other sciences. But I hesitated to say that because I wondered if in your course I should, if I took it, which I haven't, would I learn that actually there's a much larger denominator of background knowledge required to really be a killer good engineer?
Well, so first of all, I think in some ways we often overrate the amount of math and the physical sciences of chemistry and physics that we need to be good engineers. Mm-hmm. I think partially that harkens back to the 1950s when engineers wanted to be perceived as more serious players on solving problems. Up to the 1950s, engineering was largely a training around laboratories and shops. And the math content was fairly shallow.
Would you say it was more of an apprentice type
almost
training?
More like an apprentice. And there was, we had World War II, and to be honest with you, physicists played a large part in the engineering that was happening in the 1940s. And in the 1950s, engineering got together and said, we need to be more substantial in terms of the sciences and the math. And that actually had the negative impact of pushing out a lot of the design and, the making things and thinking about manufacturing, and the pendulum swung one way, very sciencey. I think we've come back to recognize that design is really important. And some other sciences that I think are starting to play a greater role include sociology and psychology and biology. And those really more centrally bring in the notion of how do we understand this thing called the human being, whether it's our bodies or our minds and our hearts.
For which we're engineering. In fact, I happened to be watching a YouTube about pocket knives, and they were talking about the ergonomics, and this guy who was reviewing pocket knives, it was all about how well it fit his hand. And I was struck that, yes, an engineer who's really paying attention needs to think about the human users. And of course, if we think about the products that we love, the best ones are intimately familiar with like the modes of use and the physical human. And, mm-hmm. and I would guess also the kind of cognitive behavioral aspects of humanity that might impact engineering solutions. So are these the kinds of things you get into in the class?
We certainly do, in terms of the physical fit, the emotional fit, and then how does that also relate to access, whether that be people with disabilities, the cost associated with it, and reactions to it. And for engineers, that gets a little squishy sometimes. I think as engineers, we're trained about quantitative data that you measure with sensors, in the sense of a thermocouple, and that represents real objective data. Right. And that, when we start doing things that are based on interviews of people, for instance, that gets squishier, and is it just opinions and more subjective, when the reality is that kind of data really can be collected and handled with high integrity. Sociologists do it all the time, and really inform how to design things that really fit human needs.
How are the students doing with this class? So I was struck just now, you said, they're used to, probably in many of their other courses, it's about objective numerical data. Are they still trainable, or are they lost when you say, hey guys, we're going to think about things in a much broader way? What's the student response to this kind of expanded way of thinking about engineering?
I think some of them come to it and are just relieved to know that there is this more human dimension to engineering. And for some of those students, it's because, in fact, they've been the only woman or Black student in a class, and they've sometimes felt they didn't belong. So recognizing that there is this how do you fit set of questions is almost a relief to them. I think, generally the engineering students we need to take some time on how do you start to read, for instance, a sociology paper. Mm-hmm. If you're really trying to understand how were the data collected, how were they analyzed, what are the conclusions, what are the limits on the conclusions, just like, when you read any scientific paper, learning to know what's a good paper. And so, for instance, one of the things we talk about in the class is, to what extent are some fields really defined based on a belief of innate ability, and that you either have it or you don't? And are there other fields where there's a recognition that you can learn to be good at that? And so, for instance, mathematics is kind of like that this belief by people in that field, you either have it or you don't. Whereas education is a field where there's a much more tolerant and, I would say, open sense of you weren't either born or not born with it, but you work hard and you learn things and you try things and you can get better at them. And you tend to see that fields that have more of a belief of an innate ability tend to be more dominated by men. And believe it or not, one of those fields is philosophy.
Oh, so this is not limited to the science and engineering disciplines.
It's not limited to the sciences. Yeah.
So philosophers think that they are born philosophers?
That there's something much deeper in your ability to get good at it.
So how have your colleagues in engineering, so this, first of all, this sounds that it's not only very attractive for students, but in many ways, this opens up the doors. As you said, people feel like, oh, maybe I belong a lot more than I thought I belonged. And that has to be a good thing. But it needs to, obviously, it needs to occur at scale in order to kind of make sure that the workforce grows. Is this catching on? How do your colleagues respond to this? And is it going viral? And I mean that in a very positive sense of viral, which is difficult to imagine these days.
Yeah. I would say my colleagues at Stanford probably do more than tolerate the course. I mean, I think there's an increased recognition that, again, engineering is more than the sciences and mathematics. And another area that is getting increased recognition is ethics too. Yes. And that really is a part of a student's toolkit, or should be a part of their toolkit, on how do they struggle with those kind of moral questions too, about who gets hurt, who doesn't get hurt. So recognizing that that's part of the palette is there. I think one of the challenges is having faculty to teach these kind of courses, because our education generally was based on the sciences and mathematics, and if we did PhDs, it was based on that. And so for me, it's been really critical to find partners in, let's say, the Graduate School of Education, in sociology, and even history, to think about co-teaching it with, because there's not a standard textbook. As we have students learn what are the issues, how do you question the issues, how do you observe where you're working or not working, and how can you affect change?
I know that one of the trends in ethics education, which I've been a little bit involved with, is that yes, you can teach a class, but really it needs to permeate the entire curriculum, that you want to be ethical always, not only when you're sitting in the ethics class. And I'm wondering if there's a similar idea here, that some of the principles of your class probably need to be more generally distributed throughout the curriculum. Is that possible?
Yes, and actually in engineering education, there's also that same debate about ethics education. Should it be a singular class, or should it be actually a way of interpreting any technical subject too? And I actually think it kind of needs both, and I can explain why. But the same thing with thinking about, and in my lab we call it thinking about the peopleness of the problem. And where are people involved in terms of who are the engineers at the table, how they're thinking about the communities for which they're engineering, and how do you get engineers to think more about that? And it can happen in classes by the kind of examples you give. Do you actually talk about some historical examples, and do you actually show a Black engineer or a white woman who is doing engineering? So it can be sprinkled in like that. You can also bring in case studies where, in fact, there were people who were ignored, for instance, in the design of things, and what were the consequences when they were ignored in terms of their needs. It does take, though, I think, a community dedicated to making sure it gets sprinkled in, and sprinkled in deeply enough that it's not just the professor saying, I talked about this, and hopefully they heard it. So that in some ways, the students also have to struggle with the issue too.
Yes, and it needs to be hard and part of the culture to have this be part of the discussion about we were talking about design, and whenever you do design, you always have requirements, and that requirement, at the requirement level, it seems to me this would have to be introduced. Otherwise, if it's just tacked on at the end, it's not going to be kind of an integral part of the solution.
Yeah, well, and that's interesting because, I think, for instance, things like design thinking, one of the earlier stages in that is empathy, of really going out and figuring out who you should be talking to, and what kind of questions you're asking them. I think engineering still has a challenge in taking that sort of data and translating it into requirements, because it's those requirements that ultimately are what you're judging your solution ideas against, to make sure that you really have achieved what you're trying to achieve. So I think there's still a lot of work to go from empathy to solid requirements.
We had a great conversation about the things you're doing in your class, and the expanding the denominator of things that an engineer might want to consider when they're identifying problems and solving them. How does this go over with industry? Is industry on board with these approaches, or are they skeptical? Are they watching skeptically, or are they fully engaged?
I would say many companies are aware that thinking about diversity and acting on diversity is key for multiple reasons. One, again, no one type of person or no one demographic has all the ideas about innovation. And so how do you get a broader range of people working for you?
And I believe there's actually evidence that this is not just like a feeling, that people have actually looked at diverse teams versus non-diverse teams, and they do better when there's more perspectives.
Yes, more perspectives. Sometimes there's some rougher edges, and there's some speculation too on why those teams are better. And some of it is that when you're working with somebody who's different, do you actually explain your point of view more deeply and not assume they actually understand? And in that explaining, you actually understand the problem more, and what potential problems there might be with the solution. So there is growing evidence, that diverse teams are good. I think companies are also aware that this generation of college students and their future hires think about diversity and want to think about it being on the agenda, and wanting to know, how is it recognized by a company that I bring different things, and do I just need to hide them, or in fact, is that going to be highlighted? I would say, one thing that companies are in some ways struggling with, so it's not unusual for a large company to form what are called affinity groups. where you might have, individuals that are a woman's group or Native American employees to think about what are issues that you particularly want to highlight, what are resources or talks you'd like to hear, and whether that's considered part of your job or is it extra, so how does it get recognized in your job description? I think is something that some companies are struggling with.
So your manager dings you because you took a few hours to participate in one of these groups, which you thought you should be getting credit for. And they're saying, well, but you weren't working on the drafts of the next whatever.
Yeah. So, I think it needs to be, more woven into job expectations on what you're doing. So I think companies increasingly are seeing it really does positively affect the bottom line to sincerely look at issues of diversity. The VMware at Stanford, the VM Leadership Lab is also looking at how these issues come out in things like performance reviews and biases. So it also takes deeper digging for a company or an organization like our university on how do biases and prejudices come out in ways that you may not even recognize and then how do you get rid of those to really make the lived experience of everyone in your organization be productive.
This is the future of everything. I'm Russ Altman. I'm speaking with Professor Sheri Sheppard about diversity in companies. And I'm going to, in my introduction, I mentioned that you worked for the big three in the auto industry. And without knowing the details, I'm going to guess that there were not a ton of other women. Please correct me if I'm wrong.
Yeah.
And so you probably have lived what you're telling the students about. And so can you tell me, how does somebody feel in that situation where you're the only woman or you're one of a very large minority, a small minority, and how do you prepare somebody, or can you even prepare somebody for the feelings and the experiences that they're likely to have as a trailblazer in one of these organizations?
Yeah, I think that in the class, we talk about finding a company where their basic values are aligned with your values in terms of the product and the processes. So hopefully you're making the choice to go somewhere where you can see the derivative is in the right direction, or they're already there.
Yep.
But there's no perfect company. And so also where you might be able to find allies, and whether those be more senior people in the organization, your manager, other people at your career stage, where you can really ask questions about the processes and how they might change. In the course, we talk about what does it mean to be a change agent, and one of the readings we do is by Deb Meyerson, who's in the business school and the Graduate School of Education, and the book's called Tempered Radicals. And it talks about how to learn to rock the boat without getting pitched out of it.
Right.
And how to frame change ideas so that they're not seen as a thing we're just doing for one group, but framing it as a way that it's actually better for everybody in the organization. So we have them think about strategies like that. We have guests come in from companies that really talk about change and affecting it within the organization. And I have to say, Ford and General Motors have been great contributors to the course.
Fantastic. So let me ask, just to do a little type dive into your past. Did you choose these companies because of a passion for the product or the culture? Can I ask, how did you get involved in that industry? I don't think of it as a woman-dominated industry.
No, it's not.
Or do I think of the products as, although they maybe should be, as especially when I was younger, I'm not sure they were completely focused on a diverse set of buyers.
Yeah. So I must admit, I like driving cars kind of fast. And I've probably had a few speeding tickets in my life. And so it really seemed like an industry, and this was in the late 1970s, where I could take my engineering toolkit and work on a product that I liked.
Yes.
It's also a product that, is of a scale that you can think about, people will buy this. And so, one of the automobiles I worked on was the Corvette. And
I've heard of it.
Yeah, and for a while there was a particular part of the chassis that had its shape because of some decisions that I'd been involved with. So there is also a sense of pride of making
Absolutely.
things for people. I would say it's been interesting watching the industry shift to rebrand itself as a mobility industry, recognizing that transportation comes in all forms. Also, work through the years on how do you appeal more to women, and women make a tremendous number of car decisions and purchase decisions, and recognize that it doesn't mean a pink car, but it means some features in terms of dealing with groceries and kids and a whole set of issues that actually being more people focused has you recognize that our car actually needs to do these things too to make somebody's life better.
Yes. So did you find you this was early in your career, and it would have been a lot to ask you to be a change agent, but did you find yourself having to play that role even then during those early career phases?
I would say to a certain extent, yes. So for instance, many of the technicians had never worked with a woman engineer. While they'd worked with women administrative assistants, which is also a very important part of an organization, they hadn't worked with a woman, and at the time I was 22. So there were a couple of things, one is young, and also a woman. So in that case, I think, some of, in thinking about it, it was how do you build relationships, one technician at a time, to have them see both I respected what they brought to our projects together, but have them respect what I could do also. So it wasn't, at the big organizational level, but it was at the grassroots level of building people connected to one another.
And so I'm sure that as you're training students in your class, there must be some students who are going into the workforce with a high probability that they're going to be the only person like that at the company, and that you're kind of forging them to be ready for that experience. And have you had any kind of success stories that, or is it too early to know if the people you're sending out are making some impact?
Well, I think, some of the advice we give and discussion in the class is how do you find allies? So that other people can also say, Mary has a really great idea. Let's give space and let her talk. So that you're not always having to say, could you call on me? Right. Other things we talk about is how do you go more than half of the way to build relationships. So if you're in a group and you're really passionate about the product, but what most people talk about at lunchtime is football, right? And it's not your thing, well, then maybe you actually have to open up the door by learning a little bit about football, and then that might extend into your interest in golf. So again, that gets to how do you make relationships.
And this clearly will, so clearly that skill set, which may not traditionally be associated with engineers, when they have it, will open doors and be a vehicle for change. You have been listening to the Future of Everything podcast with Russ Altman. I want to remind you that the Future of Everything started out as a radio show on Sirius XM, so you'll hear references to that. Now it is 100% podcast, but we still have access to the great shows that we taped with Sirius XM. There are more than 215 of them, and they cover an extraordinary range of topics. If you're enjoying the podcast, please consider subscribing or following so that you can be alerted to every new episode and never be surprised by the future. Maybe tell your friends about it too. Definitely consider rating and reviewing it. That helps us grow, improve, and also spreads the word. You can connect with me on Twitter at @RBAltman and with Stanford Engineering at StanfordENG.